So I'm going to be talking about the parameters associated with tofu pasteurization after packaging. After the draining and the shaping of the tofu, it's important to pasteurize it to ensure that the number of viable disease-causing pathogens are reduced. So in the case of tofu, anaerobic bacteria and lactic acid bacteria are organisms that can lead to tofu spoilage. So ultimately, pasteurization can not only decrease health risks, but also extend the life of the product, which can in turn increase its profitability. So the parameters that we'll analyze will be the time it takes to kill a particular percentage of the target bacteria, the temperature needed to kill this population, and the pressure associated with that temperature within the pressure cooker. In deciding the decimal reduction time, which is the time in minutes required to kill a percentage of the population, two different types of tofu will be analyzed. These tofus are lactone silken tofu and a more common tofu, which we'll just call regular tofu. The main difference between these two tofus is that the lactone silken is made with a different coagulant and is typically harder and sturdier in comparison to the regular tofu. For a package of the lactone silken tofu, which can weigh between 8 and 21 ounces, 100,000 of the target bacteria are allowed to survive the plate count. For regular tofu, 100,000 of the target bacteria can survive. And these values will be associated with NT in this equation. For N initial in this equation, which is the total number of bacteria, the user will input the amount the package weighs, which will be converted to grams and then multiplied by 100,000 because that's the maximum bacterial population that is expected to be found in a gram of tofu. So if we go to MATLAB, we can test this. The program will ask you to choose lactone silken tofu or regular tofu or any other tofu by entering the values 1, 2, or 3. So for the purpose of this program, we'll enter 1 for lactone silken tofu. How many ounces would a single tofu package contain? And you can pick between the range of 8 to 21 ounces, and we'll do 12. So the output is around 81 minutes, which makes sense in relation to our research because it says that tofu should typically be pasteurized for an hour or more. And this graph here also makes sense because the surviving population on the x-axis increases and the time needed to destroy them also increases in relation. So going back to the PowerPoint. The second part in this program will take the lethal rate calculated in part 1, and it will be used to figure out the temperature needed to kill the bacterial population. So the following equation will be used in which T temperature will be solved for. L is the lethal rate calculated in part 1. T reference is the standard temperature typically used to pasteurize, which is around 121.1 degrees Celsius. And Z is the number of degree changes required to change the lethal rate by 10 minutes. This variable Z can vary between 7 and 12 depending on the bacteria being targeted, but 10 is a common value used for these types of measurements. So we'll run the second program. And it says that the temperature should be set to 124 degrees Celsius. And this makes sense because tofu is typically pasteurized for 110 degrees Celsius or more. And our final step is determining the pressure needed to accommodate this temperature found in part 2. The Clausius-Clapeyron equation will be used to estimate the vapor pressure at this designated temperature. We'll go back. For the second and third part of the program, Newton-Raphson is used to solve for a variable within the equation. So if we run this, you can see that the pressure needs to be set to 224 kilopascals. And this graph shows that as pressure increases, temperature should also decrease. So after all is said and done, the heated tofu is dropped into a coolant basin that is just above freezing temperature to help destroy any remaining resistant pathogenic bacteria like E. coli and heat versatile strains of S. aureus and Listeria. And thus the pasteurization process in tofu production is complete.